With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question is, the unit of the rate constant of an elementary reaction depends upon you're given four options: temperature, concentration, activation energy, or molecularity. Okay. Now, if we talk about an elementary reaction, now what do you mean by an elementary reaction? Elementary reactions are the simplest reaction or the single step reactions, right? Whenever there's a reaction that takes place in various steps, then each step is considered to be an elementary reaction, right? So a single step is known as an elementary reaction. It is the simplest reaction, right? And for example, if in a reaction you have a single step reaction which is a slow reaction, okay, that slow reaction is going to be the rate determining step. If now this is the case if you have a series of reactions. If you have a single reaction, single elementary reactions, for example, you have A plus B giving products, right? This is one elementary reaction that you have. Now, for an elementary reaction, the order is equal to the molecularity. What does this mean? Generally, order is an experimental quantity. For a given reaction, order is determined experimentally. We cannot just find it out by looking at the reaction. But for an elementary reaction, for the reactions that take place in a single step, right, for a simpler reactions, one-step reactions, for that, order is equal to the molecularity. It means that the number of reacting species, molecularity is the number of reactants that are involved in the reaction. So the number of reactants involved in a reaction becomes equal to the order of the reaction. For example, if two reactants are involved in a reaction, the order of the reaction is going to be 2. That is what is the case for an elementary reaction. Right? For example, this is the reaction that we have. So for example, this is the reaction that we have. And if we write down the rate law expression for this, that will be rate constant, concentration of A, concentration of B. The stoichiometry of A is 1, the stoichiometry of B is 1. So order with respect to A will be 1 and order with respect to B will be 1, because the example that we are taking here is an example of an elementary reaction, and for that the stoichiometry with each of the reactant is the order of that particular reactant as well, right? So now what do you know? What do you know from here? That if you know the molecularity, you know the order, right? And the units of rate constant depend upon the order of the reaction. The units of rate constant K depends upon the order of the reaction. So if you know the molecularity, you know the order. And if you know the order, you can find out the units of K, right? For example, here, it is a second order reaction. So K, the units of K will be R divided by concentration of A, concentration of B. The units of rate are mole per liter per second, right? And concentration has the unit mole per liter. This concentration also mole per liter. So the units of K become mole inverse liter second inverse. So basically, the units of K depend upon the order of the reaction. If there would have been only one concentration term, then the unit of K would have been different. So the unit of K depends upon the molecularity of the reaction, right? Because molecularity determines the order, and then order is responsible for the units of K. So the correct answer for this question is going to be option 4, right? Now, temperature does not affect the units of rate constant. It affects the rate constant. It can increase or decrease with respect to temperature, but it does not affect the units. Okay. Concentration. Now, the concentration change does not even change the rate constant. Okay. So the units of concentration are not going to change. Only the number of reactants are going to increase, which is going to, when the order increases, the number of reactants are going to increase, and therefore the units are going to be affected. Okay, so that is due to the molecularity. Activation energy, no, activation energy is not responsible for the change in units of rate constant. It is only and only the order of the reaction, right? And order is affected by the molecularity in the case of elementary reaction. That's all for the question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.